Okay, so here I've listed the main differences between FLAC2D and FLAC. In the old FLAC world, it was really a true finite difference program, meaning that you had to have a structured mesh. All right, you had to have a grid. And colloquially, this was known as the IJ space. So you have X and Y, which are actual coordinates, but then you have I and J, which are the location on the grid, right? And this is the way that real finite difference programs work. If you've ever used like ModFlow or something like that. What we now have is officially a finite volume program, which means that we can have these unstructured meshes, and you've been seeing that all week. And this just makes life easier in so many ways, because you just say mesh and you get a mesh, and you don't have to try and fit it to this perfect grid. We have been doing some examples where you try to make these structured meshes, right, by creating four-sided shapes and filling them up, and you get nicer meshes, but you don't have to, which is nice. The command and fish syntax has changed. So the old FLAC was written, it was probably first written 35 years ago. I don't know, something like that. And commands and fish have been added over and over and over again as time has gone by. And so it's just this horrendous mishmash of commands and fish that don't necessarily have any structure. And the other thing that happened is that FLAC and FLAC2D evolved separately. So FLAC was first, and it had its own path, and then FLAC2D came second, and took the chance. FLAC2D is newer. It took the chance to sort of bring more sensible structure to the commands and fish. Anyway, what you have is a situation where the old FLAC and the new FLAC2D are quite different in terms of the command and fish syntax. So part of this exercise was to bring these things together and make life easier for people who are trying to use both 2D and 3D. And certainly our own consultants find this super useful because they're often using both things. Out there in the real world, there's maybe less people that use both. But if you do use both, it's certainly super awesome now because they're basically exactly the same. And similarly, the plotting is now the same in FLAC2D and FLAC2D. You should be aware, if you are a FLAC user, that not all of the functionality that is in the old FLAC is currently in the new FLAC2D. There are a couple things missing, and I'll show that in a slide. However, there are also some new things in FLAC2D that are not in the old FLAC. So this just shows a picture of what I was talking about with the meshing. With the old FLAC, you don't have IDs associated with the zones or IDs associated with the grid points. They just have a IJ coordinate, which places them on this perfect grid, right? So these are zone coordinates here: 1, 1, 2, 1, 3, 1, 4, 1, right? Everything is basically a perfect Cartesian grid. You can warp it, like in this picture here, but essentially underneath it all, topologically is just a structured grid, right? In the FLAC2D world, you don't have to do that. You can just put the zones anywhere, and they just have IDs. And you've seen that already. What that means, though, is that when you're trying to identify things, you have to do it differently in FLAC2D. So in the old FLAC world, you'd say, I need to fix the x velocity on the left-hand side of the model. I would just say fix x I equals 1, right? And that would be the left-hand side of the model because that's the left-hand side of the grid, the I equals 1 boundary. And on the bottom, you'd say j equals 1, right? And that's how you do ranges. And you've seen over and over again in this course that you don't do it that way in FLAC2D. You just give a coordinate. You could say, so fix the x velocity at x equals 0, something like that. So that's different. Similarly, with the fish, if you're looping through the zones or the grid points, hopefully you saw yesterday with Dave D that it's nice and easy to loop through all these things. You just say loop for each grid point in the grid point list, or loop for each zone in the zone list, which is super awesome. In the old FLAC world, you're actually looping through the grid, right? So you're looping through all of the i's from 1 to the number of grid points, and all of the j's from 1 to the number of grid points, and doing something to them. Because again, this works because it's a structured grid. In FLAC2D, that doesn't work. You just say loop through all the grid points, and they're in some giant list, right? Okay, just a couple other things about fish. In the old FLAC, if you've ever used it, you had to predefine if you wanted to use extra variables. I don't know if you talked about extra variables yesterday. Did you guys talk about that in the fish course? So you have these extra variables you can assign to zones or grid points or whatever. In the old FLAC, you had to tell it in advance how many extra variables you wanted for the zones, because of the way that the memory assignment works. And you could only go up to 10. I think 10 was the maximum. Now you don't have to predefine it. You can just start using them, and you can have up to 128. So just super handy. The other thing in the old FLAC is that a bunch of the data that you can access was not actually written up as fish functions. For whatever reason, they never got around to actually writing functions for these things. So the structural elements, the interfaces, and maybe a couple of other things, there are actually no functions for them. But you can still mess with the data by tapping directly into the Fortran data structures using this crazy syntax here, which is, kind of a nightmare. So it's possible to do this stuff, but it's pretty painful, right? In the new FLAC, we just have fish functions for everything, so you don't have to worry about that kind of stuff. And life is easier. There's a document in the documentation that tells you how to map from old FLAC fish functions to new FLAC fish functions. This is a very small piece of that documentation. Most of the functions in FLAC2D are the thing that you're operating on with a dot, and then the quantity that you're accessing. So zone dot something, zone dot, or GP dot something, right? And this was necessary. I don't know if they explained it to you. This was kind of necessary because we now have all the programs together in one. So you've got PFC, which you can couple with FLAC. And so if I just say, for example, in the old FLAC, the fish function used to be just density. Well, if I just say density now, it doesn't know if I mean the density of zones or the density of balls or what. You know what I mean? So you have to be more specific because these things are coupled together. So now everything has like a zone dot density or a ball dot density or grid point dot displacement or whatever, right? Oh, I don't have a slide on it, but basically the same thing with the commands. In the old FLAC, you would say something like boundary, x velocity 0, blah, blah, blah. But in the new world, that doesn't make any sense because what is that boundary referring to? Is it referring to the boundary condition of zones or balls or what? So now, again, you have to say zone, face, apply. You have to say what it is you're operating on in the command for it to work. And in a lot of ways, it's more clear and nicer. On the other hand, it's slightly more verbose. You end up typing more words, which is, slightly annoying. But in the end, it's more clear, I think. So, I'm not necessarily going to go into detail here. If you haven't used FLAC, then this is irrelevant. But there's a difference in the way that the boundary conditions are applied. I'm just putting it on the slide here. And if you want to report back, you can do that. There's also a difference in the way that the properties are assigned in some cases. In the FLAC world, and this is still true in UDEC if you've ever used it, they have this concept of assigning material properties to a material number. So you say, okay, material number 1 has this Young's modulus and this Poisson's ratio. And material number 2 has a different Young's modulus and a different Poisson's ratio. And all these zones are material number 1, and all these zones are material number 2. And it's interesting historical fact. I mean, the reason that they did it that way was just to save memory. Because in the old days, computers didn't have a lot of memory, right? And so they didn't want to have every zone knowing its own Young's modulus and Poisson's ratio and cohesion and friction. I mean, some of these models have 15 parameters, right? And so that just sucks up a lot of memory. So what they did was they said, all right, we're just going to have material number 1. It's going to hold all those properties. And the zone only knows that it's material number 1. So it doesn't have to store all that information. Which made sense 25 years ago. Nowadays, it doesn't really make sense. The ability to assign the properties directly to the zones or the structural elements or whatever is nice because then you can do all this crazy stuff we talked about on Monday, like a variation in properties across all the zones, right? You can give them a Gaussian randomness, or you can have them varying with depth or whatever, Doing this kind of thing was way more challenging if you had to assign different material numbers. You'd have to have 10,000 different material numbers, right? And in fact, the old FLAC limited you to 50 material numbers. So you can only have 50 different materials. Now, of course, you can do whatever you want. Every zone can have its own properties. So. Okay, so then that's about the differences. And then we've tried to make it as easy as possible for people to go from the old to the new. In some ideal world, we would have a straight up conversion where you had a data file in the old one, and it would just turn it into a data file for the new one, and you would run it. That turns out to be not that easy because of this crazy IJ business. You can't just map it straight over to the new system. So we're working on how to go about doing that. But in the short term, we've given you these kind of functionality capabilities here. So if you're sitting in the old FLAC, this is what the old FLAC looks like. If you haven't seen it, you've got some kind of model. Let's pretend it's a reasonably complicated tunnel model. You can just go to utility. You can go to extrude. This was actually in the old. This has actually been in the old FLAC for years and years and years. If you wanted to extrude a model to make a 3D model, so you can say make me a 3D model, which is an extruded 2D model. But we just added a button here that says, okay, just make me a FLAC2D model. So it's not really extruding it. It's just turning one 2D model into another 2D model. But it's under this extrude button. So you go utility extrude, give me a FLAC2D model, and boom, it just creates a grid file. I don't know if you guys talked about that yet. You can import these grid files. And so then when you go to FLAC2D, you can say import. You go file grid import from FLAC2D, and boom, it works. The other thing that we've given you is instead of just straight up exporting the grid, you can export the sketch from FLAC2D, from the old FLAC. So the old FLAC had this thing that was similar to Sketch, right? They called it the virtual builder, where you can draw lines and stuff like that, right? Basically the same as the Sketch. So what it does is if you're in this old Sketch, this builder thing, you can go export FLAC2D sketch, and what it does is it turns the old FLAC sketch into a bunch of sketch commands that you can run in the new FLAC2D. So you would end up with something like this, these sort of sketch commands, right? So, I mean, just for fun, I can just show you. I'm in the old FLAC. All right, let's just open whatever I was working on before. Okay, I have this model. So the one thing I can do is I can go to utility, extrude, export to FLAC2D. I can set up a file name if I want to. And then there's a checkbox here for merge overlapping grid points, because one of the ways that the old FLAC used to make this structured grid work is that it would have a bunch of subgrids that are attached to each other, right? So there's all these weird kind of attaches. We don't need to do that in the new FLAC2D, so I can just say, whenever you find these attaches, just merge the grid points together. So I say, okay. And then if I hit if I'm in new FLAC2D, then I can just import that grid. Grid import from FLAC2D. Who knows where I put it, but oh, I know where it is. Oh, it doesn't matter. Let's just do the one I prepared already. Training. I think I actually gave you an example here if you wanted to play around with it. Training FLAC2D, day one, FLAC2D examples, export. There's one there. Let's just plot it. So this was actually a grid that was created in the old FLAC and exported as a grid file and then re-imported. You can see here when I imported it, it says 2,813 grid points created, 2,768 zones created, 5 groups assigned. So I even get the group names and stuff like that coming from the old FLAC. It's pretty cool. And then the other way I was showing you can export things is if I go to build, and I'm in the virtual world here, which is, again, just the same as the sketch in the new FLAC. And I go export FLAC2D sketch extruder commands. It's actually going to export a bunch of sketch commands. And then again, I can just import that here, but this time it's a data file. So let's say model new. So I would just open it like a regular old data file. There. Right, so you end up with these sketch commands like this. So I can just run that. Basically creates the model. Okay, so that's essentially what we give you in terms of helping you get from old FLAC to new FLAC. Export the grid, export the sketch commands. There's these mapping documents that go from the old set of commands to the new set of commands, and the old set of fish to the new set of fish. You can use that, try and go from one to the other. And then the last thing I'll just talk about is what features are missing and what features are extra. Missing features in FLAC2D for now. Infinite elastic boundaries, that will probably always be missing. As far as I know, almost nobody ever uses that. So that will probably never make it in there. Fish constitutive models. It's possible in the old FLAC to write your own constitutive model using fish. It's possible that might never get in there either, because you can write your own constitutive models with C++, and it's faster and better. So we may or may not actually make this work in the new FLAC2D. Haven't decided yet. There's this concept of support elements, which are basically just springs that you can use to hold open an excavation, just simple springs. Probably that will not make it in there either, because you can just use beams instead, and it's better. Makes more sense. In the old FLAC, there's this concept of automatic rezoning. And so what that means is if you start running a model, let's say it's a slope, and there's a lot of deformation, and the zones start to twist in such a way that you can't calculate anything with them anymore. The volume goes negative, for example. It will actually rezone and create new zones with new geometries that will match that deforming slope, right? This is actually pretty cool. A lot of people use it. This is definitely something we're going to put in FLAC2D. It's just not there yet. You can sort of do it with fish right now. Andre may or may not have showed you an example of that. But it's definitely something we're going to build in at some point. I'm just telling you that it's not there right now. In the old FLAC, there's also two-phase flow. Most people use this to try to simulate more complicated saturation behavior or desaturation behavior in soils. Okay, so those of you that are soils people that know about unsaturated soil mechanics, there's all these different curves to relate saturation and negative pore pressure. You know, Van Gunutchen and McCreary or something, or Zinn and Fredland. I don't know. There's a whole pile of them, right? And people who care about unsaturated soil mechanics like to have that control over the behavior of the way that these things desaturate. That's mostly what people are using the two-phase flow logic for in the old FLAC. We are going to build that in to the new FLAC2D. I don't know if Russell talked about that yesterday when he was doing fluids. But he's very close to getting all that working in the new FLAC2D. And so you can specify these different curves for desaturation. And it's going to be awesome. It's going to work great. And it's also going to be implicit, so it's going to go fast. So the two-phase flow is mostly not required anymore once we get all this working in FLAC2D. And then the last thing that's still not in there is axisymmetry for fluid and structural elements. It's a little bit hard to picture how axisymmetry is useful for structural elements. You essentially have like a bending beam or something like that, but it does exist in the old FLAC and some people use it, so we'll try and get that working. Features that exist in the new FLAC2D that are not in the old FLAC. This tunnel designer, I don't know if you saw that already in the sketch. Again, easy unstructured meshing, which is super awesome. Much better plotting and visualization. The interactive help, which we talked about a little bit, you just press F1 and the manual pops up. There's a Linux version, which is useful if you want to run on the cloud because it's cheaper. You can do coupling to PFC. This is just a fun example that somebody did of sedimentation. So sediment landing on top of some sort of basement, which is causing deformation of the basement. So I don't know, that's kind of neat. You can do this kind of stuff now. You can couple FLAC and PFC if you're interested. There's Python in FLAC2D, which we never had in the old FLAC. There's multi-threaded fish. Fish monitoring during cycling, which is cool. Discrete fracture networks, we haven't talked about that. It's not that useful in FLAC2D yet. At some point in the future, it will become useful because the plan is to enable the putting in of a whole bunch of fractures in these models in the sketch. You can imagine right now in the sketch, you could draw a whole bunch of lines and say, here's my fractures, and turn them into interfaces. At some point in the future, we will have that more automated. So you can say, all right, give me a joint set with this orientation, this spacing, or give me a discrete fracture network, and we'll just put them in there and then turn them into interfaces. I mean, you could do that kind of stuff with fish right now. It's a little bit painful. The plan is to have that built in. So the discrete fracture networks are potentially useful in the future. Okay, that's all I'm going to say about that. And then you've got some links there. So you have this PowerPoint as a PDF if you need to report back. Hopefully it's a good summary.